I want to talk about slope. Slope is something that probably most of you have had before in class. Maybe it's been a while. Maybe you didn't quite understand it. But we have to really understand what the slope is and what it means, because it's going to become very important very quickly in calculus. In a practical sense, I like to define the slope, and we're talking about the slope of a line. I like to think of it as the steepness of a line. The slope is actually a number that describes the steepness of the line. Now, what makes slope a little tricky is there's two situations where we look at the slope. The way we first learned about slope and the way we're going to start out today is when you look at the graph of a straight line, we're going to look at what the slope is and how to determine the slope of a straight line. For example, here's a straight line. Hopefully it makes sense to you that if you think of this like as going up a hill, and you say, how steep is the hill? Well, here's a question. Does the steepness of this hill, does the slope of this line change? Because normally, oftentimes, when we ask for the slope of a line, we may be looking at a certain point. In other words, you say, what's the slope of this line at that point? Or what's the slope of the line at that point? Hopefully, common sense says to you that it doesn't matter where you're at on this line, the slope or the steepness is the same. Now let's compare that to what we're going to look at pretty soon in calculus. In calculus, we like to look at graphs also, but oftentimes it's a curve. Now, if we look at this and we ask about the slope of this line, it makes a lot more sense to say, well, what's going on with the slope? If I go down here, the slope or the steepness is, it's pretty steep here, but as I move up this line, of course, it's changing. The steepness is becoming less and less. I mean, if you can imagine walking up this hill, if you were walking up, if this was the side of a hill down here, that's pretty steep. But once you get to the top, it's not very steep at all. So what's happened? The slope has changed as you move down this line. The slope does not stay the same. For a straight line, the slope never changes. It's like the slope is constant. But for a curve, the slope changes. And that's why if you're given a curve like this and someone says, what's the slope of this line, of this curve? The next question is, well, at what point on this curve would you like to know the slope? Because if I go down here at this point and try and determine the slope, or I go up here and determine the slope at this point, those two slopes are very different. As a matter of fact, what we're going to learn pretty soon is when we have a curve like this and we're trying to determine the slope, we have to choose where on the curve we want to look at the slope. And then what we do is, at that point, we have what we call a tangent line. A tangent line is a straight line that only touches the curve at one point and runs right up next to the curve. Because what we do is we say the slope of the curve at that point is actually the same as the slope of this tangent line. So if I want to find the slope of the curve at this point, I just find the slope of this tangent line. In the same way, if I was to try and find the slope at this point, what I'm really going to do is really look at the slope of the tangent line at that point. So if you look at these two lines here, obviously they have very different slopes, very different steepness. But here, if I try and draw the tangent line at that point, the tangent line is actually just the line itself. So it doesn't really make sense to use tangent lines when we're finding the slope of a straight line. But when we're trying to find the slope of a curve, we're going to use this principle. So this is what we're going to cover later on. For today, let's talk about the idea of determining the slope when you have a straight line. And here's the whole key to determining the slope of the straight line. And actually also to write out in steps. If you have a graph and you're asked to find, and your graph is a straight line, and you're asked to find the slope, you have to choose 2 points on the line, and then you move between points like a stair step, and we do some examples. This will all make sense if this is not quite clear what I'm saying. And as you're moving between the 2 points in a stair step, we're going to determine the rise and the run. Because here's what happens. Straight line, I want to find the slope of this line. Actually, let me come back to this. Let me explain one quick thing. Let me go ahead and define how we're going to calculate a slope. So to give the formula of how we're going to calculate the slope. Although initially, I'm going to give you sort of a formula, but it's going to be in words. And actually, let me just do it. We like to think the slope as a fraction, and in the top, rise, and in the bottom, run. You've probably heard that before. Oftentimes we say the slope is the rise over the run. Rise divided by the run. This is all based off of looking at 2 points on your line. So now I'll go back to my little graph I drew. Let me just call this right here, point 1, and I'll go up here and call this point 2. What I do is I start at point 1, and I'm going to move to point 2. What I'm going to do, so here I chose my 2 points, but when I move between the points, I have to move like a stair step. I can't just move directly. I have to move either up and down or left and right. So normally what we do is we start at point 1, and I'm going to move up to get to the level of point 2. So I move from here to here. We call that the rise, right? Rise is like up and down. Rise is moving up, so we call that the rise. And then if I want to get to my second point, if I'm here, The distance I move then to the right is called run. So the rise is the distance from point 1 to here, and the run is the distance from point 1 to here. So that's why sometimes, even though we define slope as rise over run, I also like to think of rise as what I call the vertical change. In other words, vertical means up and down over the horizontal change. So once again, I'm moving between 2 points on my line, and I'm saying between those 2 points, what's the vertical change? What's the sort of up and down change? And what's the horizontal change? As a matter of fact, I could describe it a third way. The rise, the vertical change, sometimes I'll just go ahead and call it what is the up and down change over horizontal, we like to think of as what is the left and right change. So rise and run, vertical, horizontal, up, down, left, to right, there's all sort of the same idea. And let me tell you this, because when you move between the 2 points, sometimes you move up, sometimes you move down. If you ever move up, the rise is going to be a positive number. If we ever have to move down, it's a negative. You're moving left to right. If you're moving to the right, which is sort of like the positive X direction, we like to think of that as moving as a positive run, positive horizontal change. And if you move to the left, it's negative. So if I go back to my little example here, I'll just make up some numbers. Another thing, I haven't said this yet. Whenever in math, we're looking for the slope, the letter M is always used for the slope. I don't know why. Maybe it's some Greek or Latin word from years ago, but M is always designates the slope. So from now on, you'll see me use the letter M a lot. That's going to mean the slope. So we want to know the slope of this line. So I choose these 2 points. So I start at point 1, and my rise, let's just assume, for instance, maybe this is maybe a distance of 4. I went from 1 to like 5. So my rise is 4, and now I'm here, and if I go here to here, say it's from 0 to 5. So my run would be 5. So I would say that the slope of this line is 4/5. Let me do another example. How about I'll sort of draw a sort of a steep line. What if we're given this graph and you're asked to determine the slope of this line? Well, what you do is you choose 2 points. Maybe I'll just choose right here and right here. Maybe I'll call this point 1 and this point 2. And you move from point 1 to point 2 in like a stair-step fashion. So once again, rise over run. Matter of fact, in this case, if I start down here, let's go ahead and just for fun, let's do my run. So I'm going to go to here and say I call that maybe I say I moved a distance of -2. In other words, because I'm moving in the negative x direction, we call that a run of -2. And then from here to here is my rise. Maybe we'll say we went up 6. So my rise was 6, my run was -2. I can say the slope of this line is -3. Now let's talk about this for a minute. So we've done 2 examples. I just sort of made up. This one, we found the slope to be 4/5. This one, we found the slope to be -3. So first, you might notice that the slope can be an either positive and negative number, and we'll talk about that in just a minute. Also, you noticed in this case, the slope was like a whole number, like an integer. And here, the slope was like a fraction. And that can happen. The slope can be any number. Could have been a decimal. So let's just quickly make sure we understand about how we can determine whether the slope of a line is positive or negative. It's pretty simple to tell. What you do is, so you have a graph, and all I want to know is that line going to have a positive slope or a negative slope? I don't really care about the number itself. I just want to know if it's positive or negative. What you do is whenever you want to determine a positive or negative slope, you always go to the far left side of your graph, and then you're going to move to the right in the positive x direction. Of course, we're going to move along our graph. As I'm moving to the right, then the question is, am I going up or down? Well, in this case, as I trace along my graph and as I go to the right, I'm going up. So we call that a positive slope. If I had something like this, if this was my graph, so once again, I start on the left-hand side, and as I move to the right, in this case, if I'm going down, if my value of y is like decreasing, then that is a negative slope. Now let me take the chance right now to talk about 2 sort of special lines. So we know about positive slopes and negative slopes. And just to go back to reinforce, here's the first example we did. If I were to say, does this line have a positive or negative slope? Well, obviously it's going up. It should be a positive slope, which it is. And then the second example we did, if I were to say, is this a positive or negative slope? Obviously, as I move from left to right, it's going down. Slope should be negative, which it is. 2 other special lines. Let's talk about them now because these actually are very important in calculus. So let me draw these lines, and then we will use what we've been talking about to try and determine the slope. First line I'm going to choose, hopefully I can draw it pretty well. Is a perfectly horizontal line, right? It's right here. It's sort of like we say it's parallel with the x-axis, straight across. Let's find out what the slope of this line would be. Well, how do we find the slope of a line, of a straight line? We choose 2 points, and we move from the first point to the second point, and we determine the rise over the run. So let's just say we go here and here. So if I call this point 1 and this point 2, now here it's sort of interesting because if I move from point 1 to point 2, normally you move like in a stair step, right? You move horizontally and then vertically, or vertically and horizontally, whichever order you want, doesn't really matter. But here, all I can do is move horizontally. In other words, in going from point 1 to point 2, what's my rise? How much do I change in terms of up and down? I don't change at all, right? 1 and 2 are at the same height. There is no rise. So the rise is 0. And just say, for instance, in this example, maybe we say the run from point 1 to point 2, we had to move a distance 3. So we would say rise over run is 0 over 3. What's 0 divided by 3? 0. Very important, really important for calculus to know that the slope of a horizontal line is 0. Very important fact to know, to remember when we start doing some calculus problems. Let's look and say now the other kind of line I want to look at is a perfectly vertical line, right? Straight up and down. Let's do the same thing. Let's just choose 2 points and let's try and calculate the slope by looking at the rise over the run between those 2 points. Maybe we'll call this point 1 and this point 2. And going from point 1 to point 2, first of all, what's the rise? Well, in this case, since I'm going down, it's like a drop. I'll call it negative, and let's just say it's maybe -4. So the rise is -4. The run is how far it changes horizontally, how far it changes left and right. What's the run between 1 and 2? Well, actually, there is no left and right change. So it's actually 0. So the slope of a vertical line, in this case, is -4 over 0. Well, what happens whenever you divide a number by 0? Now, some of you might be thinking to yourself, well, -4 divided by 0 is 0. Well, that would be very, very incorrect. So please, if you were going to make that mistake, I hope that's the last time you make that kind of mistake. In the world of math, actually what we like to say is you cannot actually divide by 0. You can't divide something by nothing. As a matter of fact, in the world of math, whenever you're working a problem, and at some point, if you ever have this case where you're trying to divide by 0, normally you just stop and you say the answer for this is a 0 with a slash through it, which really means undefined. In other words, there is no slope. A vertical line has no slope. It's undefined. So this is very important. So really there are 4 kinds of lines we're going to deal with. Positive slopes, negative slopes, horizontal lines, slope is 0, vertical lines, the slope is undefined. All right, so now let's look at a problem. I made a graph on some graph paper of a line, and we want to go in and determine the slope of this line. So here's what we're actually going to do the rest of this lesson. Let me sort of map it out, and then we can start doing it. A big part of this lesson is going to be determining the slope in various situations. So we're saying, basically, we're trying to calculate the slope. However, we're going to have different starting points. We're going to be given different information. In other words, so far, what we've been talking about, we've been looking at graphs of lines, of straight lines. And we're going to do one of these problems in just a minute. Sometimes you're given a graph that's a straight line, and the question is, what's the slope of the line? All right, we've already pretty much done that, but we're going to do another problem again. In just a minute, we're going to look at this graph and determine the slope. That's going to be pretty easy because you've already discussed how to do it. But after that, we're going to do something else. After that, sometimes they just give you an equation. For instance, they say here's an equation of a straight line, and they'll say what's the slope of that line. All right, here we're not going to use graphing. We can just do some math, do some algebra, and we can fairly easily determine the slope of this line. As a matter of fact, let me just take a minute here. Anytime you have an equation with x and y, and there aren't any exponents on the variables, this equation is going to be represented by a straight line. So whenever you see an equation with x and y and no exponents on the variables, you know you've got a straight line. Matter of fact, this kind of equation in the world of math, they call it, this is a linear equation. So in a few minutes, we're going to do some problems. We're going to talk about how to do it. We'll do some examples of if you're given an equation of a straight line, how can we calculate or determine the slope of that line? And then there's a third situation. And here I say, they give you some information about a straight line, and from the information they've given you, they want you to find the slope. Matter of fact, sometimes, or the case we're going to talk about is they give you 2 points. They give you 2 points on the line, and they say, find the slope of the line that goes through these 2 points. So for instance, right, here's an ordered pair, x and y. So the point 1,4 and the point 2,6. So they say, all right, find the slope of the line that goes through these 2 points. All right, so we'll do that in a few minutes. So we talk about finding the slopes. A lot of times they give you different starting point. Sometimes I'll give you a graph and say find the slope. Sometimes I'll give you an equation and say find the slope of this equation. Sometimes I'll give you some information like 2 points on the line. They'll say find the slope. So we'll do graphs first, equations, and then this last one. And we've already pretty much talked about graphs. So here's actually took some graph paper, drew a line on here. When I say we've talked about it, with a graph, what you do is you just choose 2 points on this graph, and it's my choice. I can choose whichever 2 points I want. And once I know those 2 points, then I determine what the rise and the run is between those 2 points. So the key is you want to sort of choose points that are nice. And like this one right here, I might as well make this one of my points. And maybe I want to find a place where it crosses right at a nice, like maybe I'll go here. So if I call this point 1 and this point 2, then I know that my slope is rise over run. So I start at point 1 and I determine what's the rise to get to point 2 and what's the run to get to point 2. And of course we have to move like a stair step. So if I start here, then I'm going to try and go up to here. That's my rise. And how far did I go? Well, from 2 to 8 is 6, right? 1, 2, 3, 4, 5, 6. So my rise is 6, and since I went up, it's a positive 6. Now I'm here, and my run is how far now I have to go to actually get to my second point. 1, 2, 3. So my run is 3. So my slope is 6 divided by 3, which is 2. So the slope of this line is 2. And because it's a straight line, it's not going to change. As a matter of fact, just for fun, what if I had chosen this point and this point? If I would find the slope of the line between those 2 points, once again, rise over run, the rise is 2, the run is 1, slope is still 2. Doesn't change. All right. Let me do, well, I think that's good. It's not that hard. Let's go and move on to what happens if you're given an equation and you're asked to find the slope. So finding the slope when you're given a graph, pretty straightforward. So we can do that. Let's look at if we're given an equation of a straight line, how we can calculate the slope. So I'll write down that same equation. So they say, here's an equation of a line, and they want to know what's the slope of that line. This is not very hard, but there is one thing, one extra piece of, or one other formula you have to know and understand to be able to easily do this problem. And that's a formula which I'm sure maybe many of you have had before. There's this equation, this formula called the slope-intercept equation. And they like to write it as y equals mx plus b. Now, if you have an equation like this, the y and the x are just your variables. So there, what happens is you end up having numbers for m and b. For example, here's an example of an equation written in the slope-intercept form. Now here's something that's very key. Let me just say it now, and you'll see why in a minute, why I say it's important. For the slope-intercept equation, the really important fact is, that really helps is, if you want something to be in the slope-intercept equation, or if you're given an equation and you wonder, I wonder if this is in the slope-intercept form, you just ask one question, or one important fact. Y is by itself on one side. If you're ever given an equation of a line, a straight line, and y is by itself, then you know the equation is in the slope-intercept form, right? Y is by itself. So for this equation, y equals 2x plus 1, is this equation in slope-intercept form? Yes, it is. Y is by itself. And therefore, you can just, the reason why it's so nice is because this m is my slope. And basically, if I'm in slope-intercept form, all I have to do is look at the number in front of x. We also call that the coefficient. If you look at the coefficient of x, that's the slope. So for this line, y equals 2x plus 1, I say the slope is 2. What if I have what if they gave me this line, and that's what the slope of this line is? Well, I look, and it's in slope-intercept form. The y is by itself. I look at whatever's in front of the x, and that's my slope. So for this one, the slope would be -1/2. That is why knowing and understanding the slope-intercept equation is very important. Now let's go to our problem. 2y equals 4x plus 6. Let me write it down here so we can start working on it. Now, if we look at this equation, the first question we should ask ourselves is this equation written in the slope-intercept form? And the answer is no, it is not. Why isn't it not? Because for something to be in the slope-intercept form, the y has to be all by itself on one side. Here, the y is over on the left, but the problem is there's a coefficient, there's a number in front of the y. We can't have that if we want to be in slope-intercept form. We have to move or get rid of, however you want to phrase it. We have to do something with this 2 here. Now, hopefully you remember from algebra, 2 times y, if I want to get rid of or remove the 2, I would multiply both sides by 1/2. 1/2 times 2y is just y. 1/2 times 4x is 2x. So I have to distribute the 1/2. 1/2 times 6 is 3. So what I've done, I've taken my original equation and I've done some algebra in order to get y by itself. Because as soon as I get y by itself, I'm now in slope-intercept form. And once I'm in slope-intercept form, I can right away look at it and very easily determine the slope. So when you're given an equation, once again, the first thing you have to do is, if the equation is not in slope-intercept form, you get the equation in slope-intercept form, and as soon as you do, then you simply look at the number in front of the x, and that's going to be your slope. Let me do one more example. How about 1/2 y plus 3x. So this right here is the equation of a straight line, right? I've got an x, I've got a y. It's going to be a straight line, but what they're asking us is, what's the slope of the line represented by this equation? All right. First question, is this equation in slope-intercept form? In other words, is the y by itself on one side? No, it is not. So the first thing I have to do is have to do some algebra, move things around, move things from side to side to eventually get y by itself. All right, so hopefully you remember how to do algebra. In other words, look at this one. The y and the x are actually initially on the same side. I don't want that. The slope-intercept equation, the y and the x are on opposite sides. So I want to move this 3x to the other side. How do I do that? If you recall, you subtract 3x from both sides. So I'm left with 1/2 y equals negative 3x minus 1. All right, so that's better. So now at least I have the y term by itself on one side, although it's not quite like I want, because once again, I really want the y by itself. Right now, it has a coefficient that's 1/2. I really need to get rid of the 1/2. And how do I do that? Once again, remember your algebra. You would multiply by 2, which is like the reciprocal of 1/2, right? Of course, you have to multiply both sides by that. So 2 times 1/2 y is just y. Distributive property, 2 times negative 3x is negative 6x. 2 times negative 1 is negative 2. Now, I've taken this initial equation, I've basically rewritten it, so now that the y is by itself, and now that it's in slope-intercept form, whatever the number is in front of the x is my slope. So the slope of this line is negative 6. All right, so that's how we find the slope when we're given an equation of a straight line. Now let me go and take just a minute to just do a quick refresher, because this is something students forget about and you need to know it. I said a few minutes ago, anytime you have an equation with an x and a y and no exponents on the variables, you know that's going to be a straight line. There's actually, and that's true, but there's actually two other equations that give us straight lines that don't look quite like that. So let me remind you of those, because sometimes we have to use those also in math. The special case goes back to something we talked about just a few minutes ago. I'm going to draw a line on here, and then I'm going to try and find the equation of this line. Not the slope, the equation of this line. What do I have here? A perfectly vertical line. As it turns out, when you have a perfectly vertical line and you're looking for the equation of this line, you don't have both an x and y. For a vertical line, you simply have whatever the value of x is. X equals 3 means that's a vertical line. And in the same way, if you have a perfectly horizontal line, the equation of that line does not have an x and a y. In this case, it only has y. So here, if we go through y equals 5, the equation of that line is y equals 5. That becomes important because there'll be some problems we're going to solve where you have this kind of thing, and you have to know that this is a vertical line, this is horizontal. If you have both x and y, what that means is you have a line, but it has some kind of slant or steepness to it. If the line's perfectly horizontal or perfectly vertical, you don't have both x and y. But if there's any kind of slant, that's when you have the x and the y. All right, so far, we've talked about if you're given a graph, how to calculate the slope, right? Pretty straightforward. Choose 2 points, step off the rise and run. We've talked about if you're given an equation, how do you find the slope, right? You get the y by itself, and you look for the number in front of the x. Pretty straightforward. Now, how about the third cases where you're just given information about the line, and then you're asked to find the slope? And the example I gave we're going to look at is, say you're given 2 points on the line, and you're asked to find the slope of the line that goes between those 2 points. All right, so let's do that. So in this case, given 2 points on a line, figure out the slope of the line that goes through those 2 points. So for our example, we will, looks like 1 point is 1, 4. The second order pair, right? X1, Y4, right? If I were to graph it, X1, Y4. And then the second point is like 3, 5, X3, Y5, X3, Y5, right? So it's 2 points. So it's like looking at this line right here. But I don't want to graph it. I want to go ahead and just, given these 2 points, I'm going to go ahead and calculate the slope. Now here's another equation, which you probably remember from your past class. It's commonly called the slope equation. And it's used when you're given 2 points on a line, and it's a little formula that helps you to calculate what the slope is. I'm going to take a minute and explain this equation, so even though maybe you've memorized it, you'll understand it. First of all, so I got y2, y1, x2, x1. What this means is you have 2 points. Point 1 is represented by x1, y1. So you got a point. The x value is x1, the y value is y1, and then if you have your second point, we call that x2, y2. So in our case, so that when you're going to calculate the slope, it doesn't even matter which of these points you call point 1 and point 2. Doesn't matter. So I'll just go ahead and call this point 2. I'll call this point 1. So for our problem, I'm calling point 1, 3, 5, which means x1, x of my first point is 3, y of my first point is 5. Oh, I didn't write it correctly. It's supposed to be 1, 4. Sorry. You probably saw that. Let's call 1, 4.1. So x of my first point's 1, y of my first point's 4. And then I'll call my second point 3, 5. And then it's just a matter of being careful and plugging in the correct numbers. So y of my second point, I go to my second point, I look at the value of y, and it's 5. Minus y of my first point, I go to my first point, I go to the y, that's 4. Divided by x of my second point, here's my second point, x is 3, minus x of my first point, here's my first point, x is 1. So there now, I've plugged in the numbers. 5 minus 4 is 1, 3 minus 1 is 2. Looks like the slope of the line that goes through those 2 points, the slope is 1/2. Now let me take a quick minute and show you how really the slope equation makes a lot of sense of what we've said. Let's go back to graphing. Remember what we called in graphing? We said rise over run. Well, you know what y2 minus y1 is? It's the rise. This is what is the up and down change between 2 points. And x2 minus x1, what is x2 minus x1? That's the change horizontally in the 2 points, which we called the run. So that's why we go back to our graph. In a sense, this is point 1. We could have called this x1, y1, and point 2, x2, y2. And if I say the slope equation is y2 minus y1 over x2 minus x1, y2 over y1 says y of my second point, which is 8, subtract y of my first point, which is 2, 8 minus 2, which is 6, right? So really what y2 minus y1 is like my rise. x2 minus x1, so x of my second point, which is right here at 3, minus x of my first point, which is 0. So 3 minus 0 is 3, so like 3 is my run, equals 2, which of course is the slope of this line. So really, this little slope equation really is just a mathematical way to express rise over run. y2 minus y1 is what's the up and down change. x2 minus x1, what's the left and right change between 2 points. Let's do maybe one more example. How about let me just make one up. How about we'll do some negative numbers to make the math a little messier. We're given 2 points on a line. Find the slope of the line that goes through these 2 points. All right, I'll just call this point 2. I'll call this point 1. Use my slope equation. Y of my second point is 2 minus y of my first point. Be careful now, I'm subtracting a negative 2. over x of my second point, which is -5, minus x of my first point. I'm subtracting a -1. What happens when you subtract a -2? It really means you add it, right? So it's really 2 plus 2, which is 4. -5 minus a -1, when you subtract a negative, it's like adding. So it's really -5 plus 1, which is -4. As it turns out, the slope of the line that goes through those points is -1. All right, so trying to find slopes given a graph, we know how to do it. If we're given an equation, we know how to find the slope. If we're given some information like 2 points in line, we can find the slope. Now there is one more topic we need to cover, because what they do sometimes is they may oftentimes ask you to find the slope, but in some problems, they won't just ask for the slope. They will actually ask you to find the equation of the line. And normally that's done when they give you information. So that's what I want to do now. So for instance, given 2 points, find the equation of the line that goes through the 2 points. Once again, I'll just make some numbers up. Here are the 2 points, 1, 1, and -2, 5. What's the equation of this line? And normally when asked for the equation of a line, they like for you to write it in slope-intercept form. So the key is when we get the equation of this line, when we're all done, we want y by itself on one side and then all the stuff on the other side. So how do we go about doing this? Well, here is, I'm going to give you now, this is the third equation, third formula. Just to remind you, the first one was the slope-intercept equation, which we've been using. The second one, just from a few minutes ago, was the slope equation. Now here's the third one, which is very similar to those, but we're going to use this one a lot in calculus. That's why I'm doing this example now, because this is what you're going to be doing a lot of in this class. There's a third little formula or equation called the point slope equation. Let me write it out and I'll explain to you what it is. Y minus y1 equals mx minus x1. Point slope equation you use to find the equation of a line when you're given 1 point and the slope. I will do an example in a minute. Now for my problem, we were not given 1 point and the slope. We were given 2 points. But what I'm going to do is, with these 2 points, I can find the slope. And now that I have the slope and a point, then I can use this equation to calculate the equation of the line. So what happens is, the 1 point you're given is the x1, y1, x1, y1. The x and y are just variables, and then the slope is here. So let's first do this case. We're given 2 points. I want to find the equation of the line. I want it to look like this, but I'm actually going to use the point slope equation to figure it out. I need to know the slope of the line. So I'm going to use the slope equation. I'll call this 0.2 and this 0.1. I got to find the slope of the line that goes between these 2 points. So y2 minus y1 over x2 minus x1. 5 minus 1 is 4. Negative 2 minus 1 is negative 3. See what I did here? A lot of people get confused on that too. So here's a 30-second with negatives and fractions. So I initially had written this. That's the same thing as if you move the minus sort of out front. That's the same thing if you move the minus to the top. So it's almost like this minus sign can be in the bottom, can be out front, can be in the top. However, especially this, what this does not mean is you put the minus in both places, because that's actually 4/3. So that's not okay. But sometimes the minus sign gets moved around and students get confused. But anyways, the slope of the line that goes to those 2 points is negative 4/3. So now I know the slope. To use the point slope equation, I need to know the slope and 1 point on the line. Turns out I have 2 points on the line. I can choose either one. Doesn't matter which one I choose, the equation line is going to be the same. I'll choose the first point. It looks a little easier, 1, 1. So now I'm going to take this point and this slope and use it in my point slope equation. So y minus y of my point, which is 1, equals my slope, negative 4/3, x minus x of my point, which is 1. So there you go. Now the one final step is they like you to write the equation of your line in slope-intercept form, which means you get y by itself. So I'm going to multiply out these parentheses and then add 1 to get the y by itself. So I'll multiply out the parentheses. Now I'll add 1 to both sides. So 1 plus 4/3 ends up being like 7/3. So there's the equation of the line that goes through those 2 points. So once again, I ended up using this point slope equation. But to use the point slope equation, you need to have a point and the slope. Well, I've got a point. In fact, I've got 2 points. But I don't know the slope. However, when I'm given 2 points, I can find the slope. So I took the 2 points, I found the slope. Once I've got the slope, I took a point, plugged it in point slope, and there we go. Sometimes they'll make the problem even easier than that. What they'll say is, they'll say, here's what they're given. They give you the slope and they give you the point, and they say, they ask you to find the equation of the line. So the line that goes through this point and has this slope. This is actually the most common kind of problem we're going to be doing pretty soon here in calculus. You're going to see this a lot. That's why I'm going over it now. Well, you simply, I'll write it down again since you can't see it, the point slope equation. Y minus y1 equals mx minus x1. So y minus y of my point, y minus a negative 5, be careful with your minus signs, equals m, my slope, which is 4, x minus x of my point. So once again, if I want to get y by itself, this is y plus 5 equals, let's multiply this out, 4x minus 8. Subtract 5 from both sides. Y equals 4x minus 13. So there's the equation of the line, has a slope of 4, and it goes through the point 2, -5. All right, not too difficult. Now there's one last quick thing I want to talk about, because sometimes this comes up in problems, and although you may already know this and had it before, it doesn't hurt just to mention it now before we finish this out. And that's the idea of intercepts. When you have a line, intercepts. Could be a straight line, could be a curved line. Let's talk about what intercepts are, how we define them, and real quickly how we can easily calculate them if you're given an equation. First of all, in terms of, intercepts. And oftentimes you have x-intercepts and y-intercepts. So if we look at it graphically it's very easy. If you're ever given a graph and you're asked to find the intercepts, the intercepts are where the line crosses either axis, the x or the y. Now where the line crosses the x-axis, we call that point the x-intercept. And when the line crosses the y-axis, we call that point the y-intercept. Now let me explain one thing in the world of math that can sort of occasionally confuse students, and it's understandable. Let's just look at this example here. Say this is like, and this is like, so this up here is y is 4, here x is -4. So let's say for this graph, what's the x-intercept? Well, it's this point here, right? So you say it's x is -4, y is 0. And the y-intercept, you would say, is x is 0 and y is 4. Now the interesting thing is, anytime you look at an x-intercept, what is the value of y always going to be at an x-intercept? The value of y is always going to be 0, right? If I were to draw a second graph and look like this, right? There's my x-intercept, x-intercept 5, 0, right? The y is always 0. Because of that, sometimes what they do, it's almost like shorthand, or they take a shortcut. Instead of saying the x-intercept is -4, 0, in some problems, they'll just say the x-intercept is -4. Now, some students will say, but wait a second. The x-intercept is a point. It's an ordered pair. You got to have an x and a y. Well, yes, that's true. And it's perfectly fine. And oftentimes they're at the x-intercept is -4, 0. But sometimes it's almost like a shortcut to save time. Since everybody knows the value of y is always 0, it's like, why do I keep writing the value of y is 0? How about just give the important stuff and basically say the x-intercept is -4. I don't need to tell you what the value of y is, because you already know it's going to be 0. And in the same way, like for this problem, we said the y-intercept is 0, 4. Sometimes they'll just say the y-intercept is 4. All right, so I don't get confused. Sometimes intercepts are ordered pairs, sometimes they're numbers, really means the same thing. The last thing, what if you are given an equation and you're asked to calculate the intercepts? So for instance, what if I'm given this equation and I want to know the intercepts? It's actually a very simple thing to do. The problem becomes two parts. Let's first say, how would we find the x-intercepts? What do we know, once again, about the x-intercept? What's the value of y always going to be at an x-intercept? It's 0. Since y is always 0, what I can do is I take my equation and I plug you set y equal to 0. And you solve for x. So that means I set y equal to 0 to x. I'll go ahead and now call it my x-intercept, since that's what it is. And now I solve for x, or the x-intercept. So subtract 4 to both sides, divide by 2. If I do this in my head, I think you end up with an intercept of x equals -2, or if someone wanted to, I could say it's -2, 0. So if you're given an equation, you're asked to find the x-intercept. You simply set y equal to 0. Plug, I should say set. Set's a better word. Set y equal to 0 and solve for x. And therefore, if you want to find the y-intercept, you should do the opposite. You set x equal to 0 and solve for y. So you take this equation, set x equal to 0, so you have y, and now it's going to be the y-intercept equals 2 times 0 plus 4. 2 times 0 is 0. So you say the y-intercept equals 4, or you could say y-intercept is 0, 4. All right, throughout this class, occasionally they will ask you about intercepts, or they will give you intercepts. You know what they are. All right, so that's slope. You may have already known that. Maybe it's a long time ago. Maybe you never really understood slope. Hopefully you do now. Slope is very important in calculus, and you need to understand it in order to do well.